Either look like my dog dropping the baby.
Dear Lord, thank you so much for the life I have, for my school, my classmates and friends. I praise you for giving me this talent and skill. Thank you so much for my parents and teachers who impart knowledge, share their time and talent, and help me develop my faith and prepare me for a better future. Make me appreciate all their efforts. Make me obedient and respectful. What I learned, I offer back to you, O Lord. In Jesus' name I pray, amen. In the Good morning, Mr. Abrajano. Have a great day. Mabuhay.
I'm sorry.
scientific numbers. And before we will proceed with writing scientific numbers, I have a video for you to watch and determine if the video and the procedure done in writing or solving problem is correct or wrong.
I figure 75% to you, Bob, and 25% divided between the 5 plus. Either Crowbar, myself, top of the base. That's 5% for each one.
This is really genius. If it's 25% divided on the 5, that's 14% at least.
Oh, listen, Bob. I will teach you. You know what look here. I'll show you. I'm going to this up here. 25 divided by 5 is 5. You see, the 5 won't do it too well. No, the 5 goes into 25 5 times. You see, you're wrong, buddy.
Now, I'm moving on to the addition. Now, 5 into 25. 5 won't go into 2. But 5 goes to the 5 once. Now, we didn't use the 2 before, so it's down here. Now, 5 is 20, because 4 times, there you are. 5 is 25, 14.
No, look, Bob. Never let me do it. So you're not having information.
5 times 5.
5 plus 5 is 25.
That's true. I'm surprised that you're right. Now, so, what's 2 is 25. 5 times 4 is 20. 5 times 1 is 5. 1 is 5. That's
There, now I'll prove to you by addition that 514 is not 25. 4, 8, 10, 16,
21, 22, 23, 24, 25. There you are.
Okay, question number 1. Is the procedure used in solving the problem correct? Is the procedure used in solving the problem correct? No, why not? They use 3 procedures to check if the division done by Terry was correct. The first one was they divide 25 by 5. They got a quotient of 5. Okay, the second one, they got 14. To check if the answer is correct, they use multiplication. They multiply 14 by 5 and they get the product of 14 by 5. They divide 14. They multiply 14 by 5 and they got a product of 25. Which is correct or wrong? Wrong. The second procedure was they add 5 14 and they got the answer of 25. How did they get 25? They add a 4. 4 5 is equal to 20. They add all the 10. 10 place 5 plus 20, they got 25. So, we proceed with hindi siya pwede ituan ang screen ng text ng table. Okay, so scientific notation. So scientific notation contains numbers and exponents. Exponents can either be positive sign or negative sign. So if I say 178, how do you write 178 in? How do you write 178 in figure? I'd like to volunteer. 178. Okay, 178. With 1,710. 1,710. Right on 8,000. 1,710. Okay, when we write number, normally we group the number. We group it by 3 or simply replace a comma. You can say 100, you can write that 1,710, or you can write that as 1,710. Okay, so that is how we write a number. We group them, or we simply place decimal place for the number. Okay, we proceed with writing a specific number.
Can you imagine how fast I travel? Or how small an atom is?
Okay, so light travels are very steep or slow. Light travels like the lightning. Okay, very fast, very slow.
Very fast.
Very fast. It is much faster than the blink of an eye. Okay? How about the size of an atom? Very big, very small.
Very small.
Very small. So, if it is very small, can you see the atom? No. Because atom is a very small particle, very minute. That cannot be seen by the naked eye. Probably our eyes can see 1 times 10 raised to exponent 7. Okay? But smaller than that, it can't be seen by the naked eye. That's why we use scientific numbers to identify big or small numbers and write it conveniently with less numbers. Okay, here.
Can you imagine how fast light travels? Or how small an atom is? One travels at a speed of 3 million kilometers per second. While an atom is so small that it cannot be seen by the naked eye. Very large or very small numbers can be expressed in a simple and convenient way by using scientific notation. Scientific notation is the expression of a number in the form a times 10 to the n, where a is a number greater than or equal to 1 but less than 10, and n is an integer.
Okay, so A here is a number. Okay, it is a number. A is a number. where a number is greater than or equal to 1 but less than 10. It is between 1 to 10. That is what we call the scientific number. F times 10 exponent 10. F can be positive or negative numbers. Okay? So, example, 1.2 times 10 exponent 3. That is a scientific number. But if I say 14 times 10 exponent 5, is this acceptable? 14 times 10 raised to exponent 5. Is this acceptable? Why not? Okay. The rule says A, which is a number, should be between 1 and 10. No less than 1 and no more than 10. Okay.
One channel that is while an atom is so small that it cannot be seen by the naked eye. Very large or very small numbers can be expressed in a simple and convenient way by using scientific notation. Scientific notation is the expression of a number in the form A times 10 to the n, where A is a number greater than or equal to 1, but less than 10, and n is an integer. Scientific notation of large numbers. Let's begin with these. 42. 4.2 times 10 to the 1. 5,000. 5 times 10 to the 3. 320,000. 3.2 times 10 to the 5. 864 billion. 8.64 times 10 to the 11.
Okay. We can compare then the number and a scientific number. Okay, so this is 42. Okay, so 42, when we write that in scientific number, it is 4.2 exponent 1. Please note that the 42 number, where is the decimal place? Before number 4 or after number 2? Okay, there is an imaginary number here. Okay, that means 42. So, a number, ordinary number, when we convert it, write it in scientific notation, we count the number of places. This is decimal place in left or right side? Right. So you move. How many times did I move? 1. So this will become 4.2 times 10. How many times did I move? 1. So that will become the exponent. If you move the whole number from right to left, it is a positive sign. Okay? If you move a number from right going to left in writing numbers, you move left, right. If you move from right going to the left, it turns to be positive. So the absence of a sign is understood as positive number. Okay, number 2, letter B. That is 5,000. In 5,000, where is the decimal place? After the last zero. Okay, it should be here. Okay, so I will try to count the number of decimal places. 1, 2, 3. So that turns to be 3, 5. 5 times 10 raised to the power of 3. Okay, check. Number, letter C. That is, read out. Okay, we read that as 320,000. Where is the decimal place? After the last zero. Here. Okay, then we count 1, 2, 3, 4, 5. We can put it between 2 and 0 because it turns to be 32. The rule says it should be between 1 and 10. Okay, so we write that 3.2 times 10. How many places there are? 1, 2, 3, 4, 5. So that's 1. That is? Okay. Letter E. That is, this is 1, 10, 100, 1,000, billion. So we read that as 854 billion. And that's not made here. After that, here. Last zero again. There. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 6.4 times 10 exponent 11. Okay.
Scientific notation, let's begin with these. 42, 5,000, 5 times 10 to the 3, 320,000, 3.2 times 10 to the 5, 864 billion, 8.64 times 10 to the 11. Let's find out how these numbers are expressed in scientific notation. First, identify the first non-zero digit. The first non-zero digit in 42 is 4. In 5,000, it's 5. In 320,000, it's 3. And in 864 billion, it's 8. Notice that a decimal point was added after the first non-zero digit. Second, count the number of places the decimal point was moved from its original position. Third, express the number in scientific notation as A times 10 to the n, where A is a number between 1 and 10, and n is the number of times the decimal point was moved. N is positive if the movement of the decimal point is from right to left. Okay, so how is 3.4 expressed in scientific notation? Scientific notation of small numbers. Let's begin with these. 0.02 2 times 10 to the negative 2. 0.0034. 3.4 times 10 to the negative 3. 0.0000865. 8.65 times 10 to the negative 6.
Okay, how did they get the negative sign? Okay, a while ago we discussed the whole number, right? So when we move from right to left, it turns to be positive or negative?
Positive.
Positive. That means that is a bigger number. If it is a smaller number, you can see a negative, right? Okay, so, okay, we read that up. Now, how do we read that in mathematics? 200, number 3. 100, so that is 200. This one is 10,000. This is 10,000. Okay. So we change that into scientific notation or scientific number. In changing the scientific number, we follow the 3 rules. The first rule is look for non-zero digits. Letter A, number 2 is a non-zero digit. The letter B, 34 is a non-zero digit. And letter C, 865 is a non-zero digit. But rule number 2 says that scientific number should be between 1 and 10. So this will be referred to a whole number. You move 1 to 2. So you move that twice. So you write that as 2 times 10 times 10. How many times do you move? 2. Twice. Because you move that twice, the movement from left to right gives you a negative sign. Very good. So you have there 2 times 10 raised to exponent negative 2. Okay, number 2. Okay, number 2 is, we read that as letter B.
34,10,000.
Okay, 34,10,000. We locate the first non-zero digit. Rule number 2, between 1 and 10. Rule number 3, movement from right to left is positive. Left to right, negative. So, we move that 1, 2, 3. So, 3, 4, 9, 10. The power of, how many times do we move? 1, 2, 3. And we move from left to right, so we have negative 5. Letter C. Letter C is? Okay, and we move, locate the first non-zero digit. 1, 2, 3, 4, 5, 6. So that will be 8.55 times 10. And how many times do we move? 6. And we move from left to right or right to left? Huh?
Left to right.
So the sign we will use is
Negative.
Okay, next one. So, next. Okay.
find out how these numbers are expressed in scientific notation. First, identify the first non-zero digit. Second, count the number of places the decimal point is moved from its original position. The number in scientific notation as a times 10 to the n, where a is a number between 1 and 10, and n is the number of times the decimal point is moved. N is negative if the movement of the decimal point is from left to right. How is point 2 expressed in scientific notation? Do you want to know how far your favorite planet is from the sun? How is point 2 expressed in scientific notation?
And how do you express that in scientific notation? How do you express point 2 in scientific notation? What's rule number 1? Okay, what is the non-zero digit? 2. So you write there 2. The first non-zero digit is 2. So 2. Next, rule number 2. Count the number of movements. How many movements did you make? 1. So times 10. Exponent 1. Did I move from left to right or right to left?
Left to right.
So when I move from left to right, that means what sign will I use? Negative. So the answer is 2 times 10 raised to exponent -1.
Do you want to know how far your favorite planet is from the sun? Point to your favorite planet to find out.
Okay. And remain the center of the Earth. What do you call the planet at the center of the Earth? I mean, center of the solar system. Okay, the sun. Sun is the source of heat and light. What if there is no sun? Okay, why would we die? It is very cold. We can cook up with cold. We can create fire. What is the main force when we will all die without the sun? Energy. Because the sun is the source of energy. Aside from that, in food making process. For photosynthesis, the requirement is carbon dioxide, chlorophyll, sunlight, and water. Okay, so without one of those, it cannot produce food. Okay, so we point 1 planet. 2. So total is 1,000, million, billion. That is 5 billion, 940,000, million, 335,000 kilometers. Okay, very far. Okay, how about this one? What do you call a red planet? Mars. Okay, that is 207 million, 800 What planet is closer to the sun? Next. Then right is Mercury.
Mercury.
Okay. 38,394,700 kilometers. What's next to Mercury? Venus.
Venus.
107,805,000. Okay. Next. Earth. 140.
149,730,000 kilometers.
Jupiter.
778,596,000 kilometers.
Next to Jupiter.
Saturn.
Uranus. Saturn.
1,422,435,000 kilometers.
Next.
Uranus.
2,874,816,000 kilometers.
Neptune.
4,521,846,000 kilometers.
Okay. How about the last one?
5,914,335,000 kilometers.
Question. Is Pluto not part of the solar system? Is it a planet? No. You can't just say no without reason. Why?
It doesn't have its own axis.
It does, but it runs elliptical. Okay? It does not follow all other axes. So, malinis sila na natin. Ang Pluto is opposite. Nasa gilid ang dulot niya. Okay? Aside from Pluto, napag-giant mga meteorite, maunay igtuon sa Pluto. That's why tangtang siya sa pagka-member sa planet. Because may characteristics na wala sa planet. And normally they follow orbit. Okay, we have the word orbit and orbital. What's the difference between the orbit and the orbital? Ang orbiting is the pattern ng tuyo. Orbital is the kalsada ng tuyo kanan. Right? Just like the word limuot and init. You cannot use the word the way you want to use it. You can say, pagkalimuot sa panahon, pagkainit sa panahon. You can say also, pagkainit sa sabaw, but you cannot say pagkalimuot sa sabaw. Diba? So, orbit and orbital. Okay, that's people see.
Did you learn a lot today?
Okay, that's
Let's see how well you've learned the lesson for today. Try this. Express the distances of planets in scientific notation.
okay. First, Mercury. Okay. Then, how do you write the 3,394,700 kilometers? Go to the table. Do the number 3. Fine. 5, 4, 7. How about let's go next? Okay, so let's try to see it. That's not there. Okay,
Again.
okay, get it.
Try planets in scientific notation. Try again.
Number 3.
Try this. Express the distances of the planets in scientific notation.
149,700,000 kilometers. $4,521,846,000 kilometers.